So we're going to talk about more problems or really similar problems kind of overlapping, maybe a little bit more in detail, because we know we talked about the economy is going to be a problem because of climate change. We talked about ecosystems being affected because if you have a shift in a biome, okay, since biomes are determined by climate, you're going to have problems in specific biomes like forest and tundra. Tundra being the most fragile, and also because the tundra, in terms of climate change, shows a positive feedback loop, which is what? As Arctic ice melts, what? As Arctic ice melts, methane from the permafrost is released into the atmosphere, which is a greenhouse gas, which causes more warming, which leads to more melting of permafrost, okay? That's what you got to think of. And the same thing with the forest. You're losing trees, which take in carbon dioxide. Okay, so they're going to be susceptible. Or any plant life. Also, marine life is going to be affected. We've got more detailed species being affected. Birds are indicator species. Climate is going to pretty much indicate them to move, and that's definitely a factor. You've got insects, fungi, and microbes, which are going to be affected how? Possibly. This is a big topic of concern with our warming climate. They're going to survive because they thrive in these conditions, so they're going to kind of, they're growing in numbers versus the adverse effects, which what we're seeing people decline in numbers. You've got extreme weather, like we said. You're going to see waves of heat, waves of lack of water, excessive rain and cold weather too, even though that's not there. Excessive temperature and excessive rainfall, or prolonged periods of rain and floodings, as I said. Changes in crop growth. So if we have a shift in a biome from arable land or grasslands into deserts, this happens why? Let's link it to climate change and global warming and all the consequences. Okay, so the warming of the earth affects a shift of a grassland to a desert how? Droughts. So droughts are a direct result of global warming or climate change. And without water, you're going to go from a biome that has average rainfall to none, okay? Shift of biome. What else can cause a shift of a grassland to a desert? But in terms of climate change. How about excessive rainfall? What can happen? Flooding. Topsoil gets loosened, moves off. You no longer have arable land, which is our next chapter, and it's gonna make more sense. That top layer of soil is important for growing crops. If you lose that, you can no longer grow crops. Okay, so it works both ways. And then they're talking about genetically engineering crops in order to be able to tolerate these changes environments, and that's really a link to our next chapter. Did I miss anything? No. All right. So then we go to solutions. There has to be, we got to see the light somewhere. So what can we do to stop this or help this? Because we know we're at a point of no return, but we got to do something. So what can we do? Shift to reusable or what we call renewable energy, because most of these sources are going to reduce what? Emissions of carbon dioxide, greenhouse gases, okay? Because when you burn fossil fuels, you're going to emit carbon dioxide, you're going to emit nitrous oxide, both of those, water vapor, those are greenhouse gases. So we're reducing the amount of emissions. You want to reduce population. I know that's a terrible thing to say, but we know that overpopulation is linked to all environmental problems. What else? Stop cutting down forests. So that way our CO2 can be taken in at a faster pace and taken away from our atmosphere as it should be. And then we need to shift to what? So we don't just have to shift to use renewable sources. If we're going to keep burning coal, we need to make sure when we burn it, we do so how? Sustainably, what's a better word? Efficiently, which is going to be a big word for our next couple of units. We have to, efficiency is everything. I want to put this much coal in and get 10 times more energy. So that way I don't have to use as much coal, okay? So make the system, the input and the output, more efficient. So now we switch to ozone. What have you learned about ozone so far in this class? What's a chemical compound? O3. Where is it found? In the stratosphere, and when it's there, it's what? It protects us from? So it's like a sunblock that protects you from UV rays. When it's in the troposphere, can it be there? What is it like? Bad. We call it bad ozone. Why is it bad? Because it's a greenhouse gas that traps heat, re-radiates infrared rays back to Earth, warming Earth. What else? It's toxic. What else? It also leads to another major air pollution problem. Smog. So it reacts with emissions from cars during heavy traffic and forms that layer of pollution across the atmosphere. All right, so number one cause of ozone depletion, and here we're going to add, because this is a crazy fact, in the 80s, okay? So in the past, really, anybody know what it is? Hairspray or aerosol sprays leads to it. It wasn't just hairspray, it was all aerosol spray cans contained something that led to the depletion of the ozone in the stratosphere. Anybody know what it is? What chemical? It has a chlorine compound. Nitrous oxides now is something we have to worry about. I heard it. It's chlorofluorocarbons, which we know are also what? CFCs and a greenhouse gas. In addition, we have halogens and HBFCs, two other compounds that are responsible for the depleting ozone that we were aware of early on when the whole started to take place. The biggest problem with CFCs, even though they were banned by this movement called the Montreal Protocol, and you have to know that, is that they linger in the atmosphere for a long time. Nothing breaks up that molecule. So, I mean, they say it could be that long. I don't know how they did that. What they do, tag the molecule and follow it? No, I'm just kidding. I have no idea. But this is what I know based on research. CFC molecules are emitted on Earth by aerosol cans, and then they travel through the troposphere and they linger. Nothing reacts with it. They might trap UV infrared rays and re-radiate them back to Earth, warm Earth. If they continue to travel higher, they're going to go to the stratosphere. And there they react with something, which I'm not going to tell you yet, that causes it to lead to the hole in the ozone. By hole, I mean break up the molecule of ozone, okay? Yes. Yes. So you have part two done. CFCs are also toxic chemicals, corrosive, but they actually have an odor, which is different from a lot of the ones we've covered. So if I say coolants, which is our biggest problem, contain CFCs, what am I referencing? Air conditioning, refrigerators, things that have to have Freon, okay? And then also foams is another one, and solvents. Lourdes mentioned 5 seconds ago, nitrous oxide is now our actual largest ozone depleting gas. What can we do about nitrous oxide? It's naturally emitted. So we're in trouble in that sense. We cannot ban the use of nitrogen, can we? Because where is it found? Fertilizers. So agriculture is going to be a big contributor. Where else? What else produces nitrous oxide? Cars, transportation. We could probably work on that. Whoops. And combustion emissions or burning of fossil fuels and industry, as usual. All those things contribute. So these things we could probably work on, but coming up with a new fertilizer, which is an organic compound, could be a little tough. The reality is nitrous oxide should react in our troposphere and break apart. We know this from the nitrogen cycle. I mean, it just should happen. Somehow it rises into the stratosphere, lingers there again until the UV breaks it apart and starts the reaction that can deplete ozone. You're not going to have to know this reaction for the test, but I'm going to show it to you in a minute. This is the reaction that you have to do for your assignment tomorrow. I'm not going to go over this right now, okay? You have to learn it on your own, okay? I'm giving you everything else. This is the reaction that you don't have to know on the test, but before the AP exam, we'll go over it again in case it's like an essay question. So nitrous oxide somehow makes it to the stratosphere, as I said before, and it reacts with an oxygen to form nitric oxide. That reacts with ozone, my O3, and what it's doing is causing a reaction to break up ozone. That's what the hole means. Ozone breaking apart. Once you break up ozone, it's done. And then the sad part is, notice how I made it red. Now you've got this compound that was produced from this reaction that's going to react with another oxygen and make, which is going to start all over. Which is the same problem with chlorofluorocarbons, okay? Which you will have to explain. It's not a feedback loop because it would have to go from here to here, and it's not. But it's a compound that keeps being produced, and that can keep happening, I don't know how many times, but with CFCs, you're gonna know how many times, okay? All right, I also want you to know, and you don't have to know all of this, but I put it there for informational purposes, that polar stratospheric clouds kind of act like a catalyst for this reaction. So if you're in the stratosphere and you have these clouds that are located in the stratosphere, which we know should be in the troposphere, right? They're called polar stratospheric clouds. They can accelerate the rate of ozone depletion. So they help, it's like a catalyst.
And there's no way to get rid of them?
Nope. But there was a way to get rid of the chemicals, right? Now, there's a picture of the ozone hole throughout the years. You can look at that later. This is a graph about the holes. You can look at that later. Important information is that in 1980, does anybody know where this hole started? Antarctic, okay? And then a couple of years ago, they found that there's holes also where? Arctic, okay, which is another huge deal. So we had this hole for years that was concentrated in a specific area, and we were struggling knowing why, and now all of a sudden there's new holes to worry about. Yes. So this statement is actually wrong. Ozone depletion doesn't increase UV radiation. Ozone depletion, and I will fix it, and then, so it doesn't increase the amount of ultraviolet radiation that comes from the sun. It just increases the opportunity for it to come straight through the atmosphere without any protection. So those rays, instead of like sunblock, blocks specific potential of the ray, you now have a hole there which it could come straight through, okay? So this is going to lead to several environmental effects as well as human health effects. Tell me what they are. Destruction of crops. You know that crops are always going to be a lot more fragile than, let's say, you. They don't have layers of skin or protection or immune systems designed as a human, so they're going to be susceptible to damage quickly. Skin cancer. And eye cancer. So any exterior, your eyes are directly affected by UV rays, so is your skin. A lot more. If you look at statistics of how much this has increased, it's crazy. What else? Marine life is definitely affected, especially what type of organism? Plankton. What else? 2 more. And the 72 slides are over. Immune system is definitely affected. Well, when your body's trying to fight things like this, like cancer, it's kind of pushing in one direction and susceptible to other things. What else? Burns, sunburns, correct. Whoops, I just took the whole video and moved it to the side. Sunburns. Good job, we are done.